Hello, everyone. Great to be here. I'm Refik Anadol, Media Arts and Director.
And my name is Christian. I'm a data scientist.
We are coming from Los Angeles, California. Right now, we are 15 people and speak in 15 languages and in 10 countries in a small studio and practicing last almost 8 years using data and AI for public space, public art specifically. Our journey started as personally 14 years ago with pure data. The software opened my mind, the idea of using data as a pigment or painting with a thinking brush over the years. Our studio heavily focused on creating pieces across the world, the art for anyone, any age, and any background. So our purpose is not specifically focused on gallery or museums, but make art that are hopefully understood by the humanity. And we try to make mostly works in different orientations, focus on architectural scales, large scales, public space where there is no door or a ceiling, where there is no beginning and an end. And we try to create public experiences in the center of AI and data. But our journey is pretty much focusing on art, science, and technology and trying to create AI, neuroscience, and architecture and trying to understand the deep discourse and context about how humans, machines, and environments are coming together. And our pieces are in airports, such as like in SVC. We have some people miss their flights while looking at the artworks, and there are experiences in public spaces. But the whole team is generally using light as a material and trying to use expressive meaning behind information and how the technology is leading us to humanity in a new direction. And our work also focuses on immersive environments and try to make impact through in real-time activations and try to educate also public through understanding and explaining the algorithms behind many works you are seeing here. But I think like many creators, I was very inspired 2015 summer when this image truly transformed many of us. I'm working with computers since 8 years old, but never able to imagine that one day that this can be a tool for artists. And thanks to Blaze's team at Google, 2016 February, I started to become the first artist in resident at Google team that was allowed me and everyone at the studio, and actually Sumit's very exciting connection with DC again happened back in time. But as a studio, we focus on one idea, not necessarily deep dive into this rabbit hole, but really understand what does it mean to be a human and how we can use information, knowledge, and wisdom as a whole common theme, and how we can interact with latent space that is just kind of a critical thinking brush, I guess we can say. And over this study, what was really inspiring me, this beautiful book, story about Library of Babel by Burke, and the idea was, can we create this library of future one day that every single information may survive and every single human in the world can access? So we tried to create the very first, I think, application in 2016, create this a public library on a public data in a public space that you can go enter this room, and when you enter, you can interact with 1.7 million documents in real time. I think it was the very first time Levin of the Tail shader ever used for such a big image data, and we were able to classify this information thanks to Mike Taika and his guidance. It was a real-time application, both in the physical space, also in the virtual space, and we were able to even lerp between multiple different, lower dimension reduction of this archive. But we were speculating what happens if there is no search bar, and what happens if an information in a library where we learn the truth can dream. If a machine can learn, can a dream question? So I think we're just obsessed with this idea of how we can turn information into knowledge, eventually wisdom, but how can we do it through not personal data, but using collective memories, specifically many different information. And I think that was a time, again, thanks to DC again, 6 years is AI is 60 years, I know, but this moment was super exciting. It was the first time we were training this moment, getting this latent walkthrough on the DC again, but the question was this is a beautiful information, but how can we turn this into a more three-dimensional pigmentation, and what else can we do with that was a much more challenging question. And I think here, thanks to Christian and many other our team members, the last 6 years was very inspiring, and we so far download more than 3 billion images and trained more than 100 AI models. And maybe Christian, please.
Yeah, so the last few years, we've been working really hard on building pipelines to visualize and explore a bunch of different data sets. Mostly we're focused on nature, culture, architecture, just other fascinating areas like that. And of course, thanks to an amazing team, and PyTorch in particular, we've been able to go from some very humble beginnings of just using VGG16 and StyleGAN, and we've been taking this from about 10,000 images, 20,000 images, and now we've scaled and trained over 100 neural networks on more than 3 billion images since 2016. We create a bunch of different tools, mostly for data visualization. So this is a bunch of graphs. We have an amazing tool called the GAN browser, which we'll show a little bit later. We work with image embeddings, we work with audio, we work with text. Really, really heavily focused on data cleaning as well. Super important for the GAN pipelines. Creating tools like that is amazing. And honestly, thanks to PyTorch, we've been able to scale this and deploy it on hundreds of cloud computers and work with people all around the world.
I think as our projects got deeper into the remembering and transmitting knowledge and after AI, we thought more about how memories, in this case, collective memories, which is like the leftover, I guess, memories in our life, we thought that how memories were actually not static like recollections, they are something in flux. And I think, as Carl Sagan also mentioned, we believe imagination can also push us to a new dimension. So last several years, we really focused on this data pigmentation idea. Very obsessed with fluid dynamics, more than, I guess, now 12 years. We learned that actually every information, every archive, and every basically memories of this collective context creating a different behavior. So we really focus on now, last 8 years, different models of fluid dynamics, both in real time, pushing computer graphics, and try to create these new ways of data pigmentation. We work with brain data, e.g. fMRI, DTI, heartbeat, skin conductance. We work with high-frequency radar activities off the surfaces of the oceans. We work with urban culture, and as you may see here, the next one, which is the exciting one, even like New York, for example, 4 years ago, 113 million images of NYC in this data set.
This was a particularly great project for us. This was the first time we really worked with a really, really big data set. I think actually at the time this was the largest data set used for a piece of public art. So this was a great accomplishment at the time. To get to this stage is a lot of work, right? Of course, it starts with data collection. Then it goes into classification, image cleaning, and then finally GAN training. And so this tool you're seeing here is actually, oh, wait, can you go back a second?
Yeah, that tool was creating these outputs, by the way, sorry.
Yeah. So this tool, what you're seeing on the left here, is actually clustering of all of the GAN images. And so this is the GAN images in latent space. And so the output on the right, as you traverse through the latent space on the left, you'll actually see the GAN image change.
And actually, the cleaning data process and getting really attention to curation brought us these beautiful outputs through different realities. But I think what gets really inspiring is how can we use machine learning algorithms not only just create the art or the context, but can we create a kind of a narrative, a scenario by truly being true to to this context of algorithms we are using, libraries we are using. So the project kind of created this very fun imagination, what happens if an algorithm becomes a space. For example, with G16 here, we are very obsessed with these deep neural nets. What happens if you can fly in it and somehow feel connected with the machine mind, and if we can understand this neural net architecture as a space, as a sculpture, then can we step inside the GAN algorithm and somehow feel the fluid, interpolation between latent spaces in 18-channel projection and 32-channel sound. And by the way, the sound is also based on back in time RNNs. We work with the TV station sounds and radio recordings and many others. This feeling of stepping into this new reality, kind of an artificial reality. But what was amazing in these exhibitions, we always show where the code comes, the contributions, and the algorithms, where they're connected. And I think these exhibitions created a safe and secure space. People felt connected and meditated, and we got incredibly positive reactions across the world and across different, culture. So we learned that opening the behind the scenes open source culture and defining the context truly make a different and a positive impact. And not only just that, for example, we are recently working with beautiful data sets such as in Rumi, Persian poets, 19 language of Masnavi. Maybe Christian can talk about this part too.
Yeah, so what you're seeing here is actually dimension reduction. So for this specifically is, we work with images and audio and text. And we go through, we do classification for depending on the different data set, and then we go through a process of PCA and then UMAP to actually create these 6-dimensional visualizations. So now here's another one from a project we worked on recently for Mozart. So a lot of this is audio data. We also have a set of images for this as well. This is a terrific pipeline. Of course, one of the really important things for us to do is this data exploration. And often we find ourselves working on unsupervised learning rather than supervised learning, because when you work with these public data sets or you work with things like Mozart or something else, it's so much more valuable to see what you can actually learn from the data rather than what you can try to force the data to conform to.
And many of these research also goes back to the researchers who have been putting this data together. We try to share our findings and if there's anything unique for them, and try to make engagement with an academic context who is giving the data to us as well. But at the end, we found these forms as kind of a sculptures or data universes which represent the information in 6 or 7 dimensions. But at the end, maybe we can see X, Y, Z, RGB, but in the final context, I feel like there are kind of universes that we can fly in and understand the meaning of information and knowledge. And of course, the imagination goes a little bit more exciting when we start thinking beyond that. For example, these are last 3 years of research, a pandemic research, that we were super inspired by nature. I think and then the inspiration in nature and the idea of metamorphosis became a very fun research. Here we have this beautiful data set of 75 million flower archive, cross-checked by the Smithsonian, 16,000 species. We made this another a generative model. But what was funny is what happens if we just not only create, by the way, the sound is also generative AI as well, but what happens if we can also feel the scent of this AI? So thanks to friends at Firmenich, last 3 years, we are working with their amazing AI called Charlie, trained on 500,000 molecules. Unfortunately, this AI is left over because it's a very expensive molecule creator that none of the brands can use it. But we thought, what happens if we take this idea and run their 14 unique molecules through this mini machine, and when you enter this space where the machine can dream these flowers, and the sound and the scent of AI. So right now it's inside London, open and free for everyone, and if you're interested, and happy to share. And we found that it's also very stimulated where the metaverse becomes inspiring, that physical and virtual world collides, and the AI demystifies the reality around us. And we get a beautiful reaction as well, and then so far from any age, any background, people are truly enjoying this experience. And this model, not only just in an immersive room, just recently, we are exploring this same idea thanks to, again, PyTorch, the speed and the process that goes beyond this is very intense. We are right now running the same idea on a real time on a stage in performances. And also this, by the way, performance has a scent as well. And we are right now seeing real time how, again, thanks to PyTorch implementation on a DJX station and running pretty much real time while they are performing. And we also took this idea, what happens if we take the same idea maybe on a building. Here we are watching in Berlin at real time, again, running the browser, this time using the weather conditions, such as the Berlin local nature data with the Berlin local weather data, and we are giving a life to a building through the same model as well. And the other, maybe the last project that we would like to share today, which is right now in New York at MoMA. I think it's the very first time generative AI is publicly available and in the collection of a museum. They would like to share this project as well.
This is a particularly exciting one as well. For this project in particular, we're actually using real-time GAN inference using audio data and motion tracking data from the lobby itself and also weather data outside. For myself, I think we really started doing this in 2016, and over the course of time, obviously I've seen PyTorch grow a lot and implemented PyTorch everywhere. We've done some great work in that time period as well, and I'm super excited to see what's coming next for both PyTorch and us.
And our curators, Paolo Antonelli, Michel Coe at MoMA, trusted the process and gave us the entire MoMA archive. By the way, MoMA is a very visionary institution. They open sourced their data in 2016 on GitHub. So it was a very visionary institution. And what we did is took the Agnes Gand open lobby. On the left side, you are seeing a 25 feet by 25 feet media wall, which is an 8K by 8K resolution. And we have to upsample our, first of all, neural net to be able to create a real-time application. Also, in this image, if you look at the ceiling, we have a real-time camera and a microphone and a real-time weather API from the literally 3 buildings right side. Sorry, we are getting a real-time information and literally real-time inference, this kind of artwork. These are 3 different UIs that is running on a real-time engine. When you go to the artwork, you can real-time see what exactly that given time that we have these clusters on the upper left you can see, and then kind of machine serendipity or kind of machine imagination can plot new ways of creating new artworks. But the fun was they were truly looking for not realistically finding the same pattern, but the curators were pushing us for the fantasy, like dreams and hallucinations, which was much fun than just trying to mimic the reality and try to create another Monet or a Starry Night, but more about what else can we do with that and how the machine maybe creativity become part of these new latent walks. And we also took this challenge and looked at with the curators to give meaning to this like unknown universe. And even though we love Stable Diffuse, Midjourney, DALL-E, and we were very closely working with all these friends, we found this interpolation language and this true control much more has a fidelity and much more connection with the poetry inside the data. And eventually, you may be seeing this a lot, but in our work, we are really like taking the raw outputs from the neural net, but always try to give this kind of data pigmentation where 100+ million molecules shape-shifting through certain fluid dynamics behaviors, and we found much more fun and again diversity through this research. And if you go to the lobby, you will be able to see 3 different artworks, 2 of them completely generative, and 1 is a pre-computed. And this is Christian, by the way. And one fun data from the security team at MoMA, we believe their data more than ever because they're there for 10+ years. They said it's the first time they are seeing bigger reaction than their famous work, Van Gogh's Stare Died. And it's the first time they are seeing all the ages engaging with artwork publicly. And it's a very exciting for the MoMA, for the institution, and trying to make this accessible for humanity. I think as a finale, we can easily say that AI and creativity opening a beautiful senses, and it's pretty clear that in every engagement and every different public art creates a big impact. And today we would like to show about and share and also call for action, I guess, from a community like yourself. We are opening our own metaverse museum or artificial reality museum in Los Angeles next year. And we are a small group of people, but we believe that bringing attention of the open source community to our research may bring much more impact than creating another a cheesy model of business. We just didn't want to do that, but we would like to create something purposeful and meaningful as a means of art experience. We have 2 big dreams that we'd like to show today. One of them is mental health. We believe that right now we need some different ways of thinking about the mental health context. We are heavily researching about how to quantify the impact of AI art in the human mind, and can we bring this to the across the world and as free as possible. And we are looking for support of this specific research. And secondly, I think this is really the most, I guess, spiritually connected project. I was very fortunate to live in the rainforest in Amazon, in Brazil, with a beautiful and very challenging, takes 14 hours to go through this snake Amazon River, and live in this Acre area with an amazingly divine humans called Yavanava people. They were 1,200 people. And this is Nishiwaka, and it is Putani and his wife, and these are the leaders of this small tribe. And what we are hoping is, instead of creating another just data set randomly, we want to co-create and work with these incredible people who have been willing to work together. You had to live 1 week with them before starting the work, but it's a very interesting world. There's no contract that we know, this is just really not a different spiritual connection. But our hope is co-create. And the number one problem we found that the language preservation. Unfortunately, there's only 57 people left that can speak this language. We are looking for support, how to preserve a language for indigenous people, and how we can open source for other indigenous people. And the second is how we can co-create something meaningful and purposeful. Because the world has enough problem, and we would like to bring hope, inspiration, and joy with AI and art. Thank you very much.